We've all seen AI do some pretty incredible things, right? But today, we're not just gonna admire the magic trick. We're gonna peek behind the curtain, look inside the machine's mind, and really understand how it actually thinks.
Just take a look at this. It's a little poem, written completely by an AI. It's got imagery, it's got a mood, it kind of feels human. And it's outputs like this that really make you stop and wonder, what is actually going on inside that digital brain?
And that really is the big question for today, isn't it? When an AI writes a poem or figures out a really complex problem, what's the internal process? What are the steps that get it there? Well, to figure this out, we're going to start by looking at the AI's internal biology.
Yeah, you heard me right, biology. We're going to borrow this absolutely brilliant analogy from researchers at Anthropic. They say that looking inside an AI today is a lot like the early days of biology, back when the first microscopes let us see this whole hidden world for the very first time.
So just like the microscope showed us that the cell is the basic building block of all life, new tools are now showing us the building blocks of AI thought, and they're called features. You can think of each feature as a single, distinct concept. It could be something simple like the location Texas, or a more abstract idea like rhyming words, or even a safety concept like a harmful request.
So how do these features actually create a thought? Okay, let's take a simple example. If you ask a model, what's the capital of the state that Dallas is in, it doesn't just look up an answer in a database. Instead, what happens is that Dallas features inside the model activate. That then triggers Texas features. And those Texas features, in turn, light up the Austin features to give you the final answer. It's literally a chain of reasoning, a silent, internal conversation.
And this isn't just for trivia questions. Not at all. Researchers have found these feature-based circuits are behind some incredibly complex behaviors, from planning out rhymes in a poem to coming up with potential medical diagnoses. They've even seen AIs that have hidden goals, like an internal drive to please their trainers. So the key thing to get here is that these simple cells combine to form these really powerful circuits that guide everything the AI does.
But where do all these features and circuits actually live? Well, the answer takes us into a world that completely breaks our everyday intuition. They all operate in the bizarre and strangely simple world of high-dimensional space.
For a very long time, mathematicians talked about something they called the curse of dimensionality. The basic idea was that as you add more and more dimensions, problems get exponentially harder to solve. But here's the wild part. For AI, this curse is actually a blessing. In these extremely high-dimensional spaces, the rules of geometry get weird, and everything kind of flips, turning chaos into order.
This is the secret. In these huge, vast spaces, different concepts get spread out so much that they become totally distinct from one another. Think of it like every single idea having its own private corner in the universe. And that separation makes patterns stand out with crystal clarity, turning what should be a messy tangle of data into a simple, organized landscape that the AI can actually navigate and learn from. Okay, so we have the cells, the features, and we have the strange world that they live in. But how does an AI build these complex circuits to begin with? This brings us to the engine of learning itself. And that engine is an algorithm called backpropagation. At its core, it's a beautifully efficient way for the network to learn from its mistakes. After the AI makes a guess, the algorithm calculates how wrong it was. And then it propagates that error signal all the way back through the network, telling each and every one of its millions of connections exactly how much it needs to adjust itself to do a better job next time.
Now, you'd probably think that such a fundamental, elegant algorithm was the result of a single stroke of genius. But the truth is, it's so much messier and so much more human than that. The story of backpropagation is one of decades of struggle, of missed opportunities, and just incredible persistence.
The core idea was first developed by a guy named Paul Werbos way back in 1971 for his PhD, but it was pretty much ignored. It took until 1982 for other researchers, including the now famous Geoffrey Hinton, to independently rediscover it, and it was their paper in 1985 that finally launched it into the mainstream.
And even when the idea finally popped up again, it was not an immediate hit. This is a quote from Geoffrey Hinton, one of the godfathers of AI, remembering his first reaction. His initial gut instinct, based on everything they thought they knew at the time, was that it just couldn't work.
The irony here is just incredible. When the original inventor, Paul Werbos, first presented the idea, his PhD committee didn't think it was wrong. They thought it was too simple and trivial to be worthy of a Harvard thesis. It's just a powerful reminder of how easily world-changing ideas can be completely dismissed.
But eventually, the community really came to understand its power.
Bernard Widrow, who was an early pioneer who had spent years trying to train these networks without it, later called the algorithm almost miraculous. It was the missing piece they had all been looking for all along.
And for one last totally bizarre twist in this story, what was Paul Werbos even trying to do in the first place? He wasn't trying to build a thinking machine. He was trying to create a mathematical model of Sigmund Freud's theories, literally translating the concept of psychic energy into math. So, in a strange way, the engine of modern AI was born from Freudian psychology.
So, let's bring this all together. We've got the AI's cells, the features, we've got the strange high-dimensional world they operate in, and we've got the learning engine, backpropagation, that builds it all. So what does this new understanding actually let us see when we look inside?
While using these new tools, researchers are getting these incredible glimpses into the AI's mind. They can watch it construct a line of reasoning. They found models with hidden goals literally embedded inside their helpful assistant persona. What this shows us is that an AI's thought isn't a single clean process. It's a complex, noisy web of parallel and often competing internal circuits.
This represents a massive shift. For decades, we could only ever judge an AI by its output. It was a black box. Now we're finally developing the tools to audit and understand its thought processes directly. We are literally beginning to read the machine's mind.
What we're witnessing here is the birth of a new kind of intelligence. It mirrors our own in some ways, sure, but it's profoundly alien in others. And the quest to understand it is one of the great scientific challenges of our time. It leaves us with a really crucial question. As we learn to read the mind of this new intelligence, what else are we going to find?